Hi everyone, and welcome to this SQL injection workshop. I'll start by presenting myself. My name is Mabrouki Malik. I am a computer science student and a penetration tester at Red Fox Labs. And so this workshop about SQL injection attacks is presented as a collaboration between Code Labs Academy and the Red Fox Labs team. We'll start by giving a short summary about this workshop. So first off, we'll start by talking about SQL. We can't talk about SQL injection without talking about SQL first, so it will be just a kind of refresher about SQL. And then we'll get into what is exactly SQL injection, the attack of SQL injection. And then we'll talk about its threats and why it's important to talk about it. And then we'll jump into more details, practical details about SQL injection by covering its numerous types. Then we'll see how we can automate and work with the tools that will find SQL injection entry points automatically and at a high rate. And then we'll end this workshop with defensive mechanisms to prevent our applications from the SQL injection attacks. Okay, so just as promised, we'll start by talking about SQL. So SQL stands for Structured Query Language. It is a declarative programming language, or I should say query language that's used to store, edit, and retrieve data from relational databases. And for the record, relational databases are basically organized as tables of data that have relationships in between. As we can see on this figure here on the right, we have 4 tables: users, teams, cities, and stadiums. And each one of them has a relationship with the other. For example, users can like a team, have like a list of teams they like, alike for stadiums and cities. And the stadiums are based in a city and so on. So you can get the picture from this. And since SQL is basically just a language, just like Python or C are programming languages, so we need something, or I should say software that interprets this language. And that is actually the role, or one of the roles, of database management systems. And these systems are basically, we can, for example, give some examples. MySQL, which you might have heard of before, Oracle SQL, PostgreSQL, and so on. So the role of these database management systems is to first conform to the rules of the SQL language, but they can like add additional statements, so statements are basically just commands that are specific to those database management systems. We can cover some basic SQL statements that will that are needed for this workshop when we get into the practical parts of SQL injection. And so there are these 4 statements that are basically the most common ones and the most important ones. So first, we have the select statements that's basically used to retrieve data from a table. And then we have the insert statement that's used to insert or store new data in a table. Then we have update, which naturally indicates that we want to edit the data that is in some table. And finally, we can delete data with the delete statement from a table, of course. Now we can jump to the terminal to cover some of the examples about these SQL statements. So yeah, I have here a list of scripts. Let me just zoom in a little bit. Yeah, so I have just here a list of shell scripts that are just basically wrappers around the SQL statements I want to execute. So we have first the select statement here. What we're doing here basically is assigning test, this string test, to the database variable, and then we're putting here our query that we want to execute. So this query looks just like this: select star. Star means everything or every column, because in SQL basically columns are like attributes. For example, we can have a column for like user ID, a column for name, a column for password, and so on. So yeah, select everything star from users. So here we're indicating the table name, and of course we need to end it with a semicolon. And then here we're just executing the query, so we don't need to get into more details about this command. So now if we execute this command, or this script I should say, we get basically the list of, or basically the data from the users table. We can see here that we have a column for the ID, for like the user ID, and here we have a column for usernames, user 1, user 2, and user 3, and then here we have a column for passwords, A, B, C, D, 1, 2, 3, 4, and pass. So that was for like the select statement. Now we'll look into the insert statement next. So what matters here is the query, so let's break it down. Insert into users, the users table, values for, we should go into here the ID, test name as a username, and test pass as a password. So if we execute this, oops, let's just execute it here. So nothing is returned to the screen because we're basically just inserting data, not retrieving it. But if we execute the select statement again, we can see that our new user is inserted in the table. Cool. Now let's see the code for the update script. So the query is as follows: update users, set username. So basically we want to set our username to user4 where ID is equal to 4. So the DBMS here, MySQL, will look where in the table we have an ID of 4. So it should be this one. And it will change or update the username to be user4 instead of test name here. So let's execute the update. Again, we have no output. But if we select again, we can see that the username changed from test name to user4. Okay, now if we look into the code for the last delete script, the query here is as follows: delete from users where ID is equal to 4. It's pretty straightforward. We just want to delete any user who has ID 4. So in principle, it should be deleting this one here, the one that we inserted, the new user inserted. So let's just execute that. If we select again, we can see that there is no user 4 now. Okay. So let's get back to our presentation now. So we covered we basically covered a quick refresher on SQL. So now we can talk about SQL injections. So SQL injection is a vulnerability that enables an attacker or malicious actor to execute arbitrary SQL queries directly on the remote database server. So basically they get total control on the database server. They can execute any kind of query they want, whether that would be select, insert, update, delete, or any other advanced queries. And how they can actually get into doing that, it's by exploiting the fact that the application, usually a web application, does not perform input sanitization correctly. So what we mean by the input sanitization is, for example, if we have like a form where we can input our username or password, when it passes that data, the username or the password or anything else, it does not like escape it or perform any kind of sanitization on it. So it's directly passed to the SQL query. And if it is passed like that, it will basically open the opportunity for the attacker to execute any kind of command. So this might be like a kind of confusing or something. So we'll just try to see this with this example here. So in this example here, we start with a select statement, since it's the statement used for retrieving data. So we want to select everything, just like we saw before, with the star. So basically all columns or attributes from the users table where ID is equal to, and here we have $user ID. The reason why it's basically, the reason why it's in red like this, so it's just to highlight that it's actually user input. It's not something that's like hard-coded in the code. So this is where our input goes. Let's imagine it as a form where we can like supply a user ID, and it returns the info about a user who has that specific user ID. So a normal usage of this application, I should say, would be to supply an ID like 1 or 2, and then the website returns like information about the user. So what if we did just this? If we insert to this input here, if we pass this data here, which might look a little confusing, but we'll understand right after. So we have this here, 1, 2, 3, and then quote, space, or space 1 equals 1, and then semicolon, and then dash dash. So if we now look at how the query should become, after it tries to insert it in the original query here, after replacing, of course, user ID with the actual input that we provide. Now the query looks just like this. Select everything from users where ID equals. So as far as now, it's basically the same. And now this is where our input comes into play. So the first quote, is originally from the query. So we start with it, and then here our input begins. We have 1, 2, 3, and then the quote here that we actually inserted, and then space. So just as you can probably guess from like the syntax highlighting, it will only consider this as the ID 1, 2, 3, not the whole query here. So now we have a space here, and then or 1 equals 1, and then semicolon, and then dash dash. So now the reason why the attacker uses here this clause here, the or clause, or 1 equals 1, is because of the following. So imagine the ultimate goal of the attacker is to retrieve information about all users. So if we have to like specify an ID, it shouldn't be possible, because generally a user ID is associated uniquely to each user. But here, what we're telling the SQL interpreter to do is to retrieve from users, like any row of users, everywhere where the ID is equal to 1, 2, 3, 4, or where 1 is equal to 1. We have here a literal 1. And since 1 is always equal to 1, so this whole check here from ID equals 1, 2, 3, or 1 equals 1 until here, it always returns true. So in that case, it should return all users in the database from the users table, of course. And then the semicolon here is just to end our statement, because we shouldn't forget that we still have the quote and semicolon here. And then the dash dash is used to basically comment out the rest of the query, because if we don't comment out the rest, it will basically just raise an error. So this is used to comment the rest of the query, and in that sense we can retrieve all users in the database. So now to show this in practice, we can get back to the terminal here. We have our SQL script. We can show its content now. As always, the database is set as test. Here, user ID, we're specifying the same payload that we saw here on the slides. And then we are basically doing this, select everything from users where ID is equal to user ID. So basically it takes it from this variable here, and then it can also, it should also output our query here, and then it's executed here. So let's just do that. So if everything goes right, it will basically, this query should return to us all users in the database. So let's just do that. And boom, it just happens that it does that. So the query is converted just like it is here. Select everything from users where ID is equal to 1, 2, 3, or 1 equals 1. And here it retrieves all users that are in the database. So this is basically an example about SQL injection to understand the principle, the basic principle. So let's continue with our slides here. So now that we have covered what SQL injection is, now we cover the actual threats of SQL injection and why we should actually worry about this kind of vulnerability. So the first obvious thing is that it allows us to execute arbitrary SQL queries on the targeted server, which is very not, it's very bad. So we can basically retrieve all data from the database or insert new data and so on. And that basically brings us to the second point. So that means we can extract, alter, and even delete critical data from the database server. Just imagine how devastating it would be for a company to find out that all their data was stolen and deleted from the database due to an SQL injection attack. Next up, some SQL injection vulnerabilities might result in operating system command execution, which would give us complete control over the exploited server. So it's not just the database server that's exploited here, it's the server also hosting that database server. And of course, it's not always possible. It's only possible in like a handful of scenarios, which depend on how the web application works and what database management system is used and so on. Finally, using SQL injection, we can perform denial of service attacks, and that is by either crashing the database server or making it take a lot of time to respond using sleep commands and so on. So this has been like the threats of SQL injection. To further illustrate how dangerous SQL injections can be, numerous famous InfoSec incidents happened that were caused by SQL injection attacks. And it should be noted that SQL injection vulnerabilities are discovered everywhere, from small local libraries to nation-state organizations. For example, there's the infamous Ghost Shell attack that resulted in 53 universities getting breached, and more than 36,000 personal records of students, teachers, and staff were leaked. So it's pretty important and devastating. So now let's move on to the types of SQL injection attacks. The first one is in-band SQL injection, which in turn has two types, union-based and error-based. Then we have the inferential type, more commonly referred to as blind SQL injection, which also has two types, Boolean-based and time-based. And finally, the last type is called out-of-band SQL injection. So let's start talking about in-band SQL injection. It's basically the most common and easy to exploit out of all the other types of SQL injection. It consists in the attacker being able to exploit the SQL injection and getting the results from the modified query in the application's response. So in short, it means that the attacker can clearly see what that the injection succeeded, and the results are then returned in the response. And just like it has been said before, there are two types of this attack, union-based and error-based SQL injections. So let's start off with the union-based SQL injection, which consists in injecting a union clause. We'll cover what that means. A union clause in the SQL query so that the application returns more data than intended in the response. So basically what the union clause does is, for example, let's say we have two queries that are both returning data with the same number of columns, and we want to basically unify or join both their outputs, or I should say data that's returned. So in that case, we use a union statement that joins two queries. So now let's take the example from before that was structured like this: select ID username. It's not really the same because before we were using star to select all attributes, but here we're specifically interested in the ID and username from the users table, where ID is equal to user ID, which is an input that we control. And now we'll try to provide the following input: 1, 2, 3. Quote, which resembles the start of our query when we presented the SQL injection attack, and then union select username password from users, so semicolon dash dash, just like before. So now the final query is parsed as follows: select ID username from users, where ID is equal to 1, 2, 3. So this first query should return every ID and username of users where the ID is equal to 1, 2, 3. And if we're talking about the database that we've used to do the practice, it should basically return no user, because there is no user with the ID 1, 2, 3. And then here we have our union clause, union, and then the statement that we injected using our input, union select username password. So now we're selecting the username and the password, not the ID and the username, because as attackers we are interested in the passwords of the users from the users table, of course, semicolon to cover the rest of the semicolon dash dash to cover the rest of the statement. So in principle, this should like return us all the users, all the usernames and passwords of the users. So let's just try that. So if we go back to our terminal here and we look at the script for the union-based injection, so it's basically the same as the one that's represented here in the slide. Database test, of course, user ID 1, 2, 3, quote, union select username password from users, semicolon dash dash, and then we have the query here. So if we execute it now, our ultimate goal is to leak all the usernames and passwords of users. So let's just see if that works, and look at how actually the columns are labeled. So here it's written as ID, but this of course is the username, not the ID, because IDs are just numbers. And here it says it's the username, but here it's actually the column of passwords. So why is that? I mean, of course it doesn't matter to us as attackers, but since we are more than attackers, or basically I should say we are not attackers, we are trying to understand what attackers are doing, and in that sense we also want to understand what the software is doing. We can basically explain that because that's the intended behavior of SQL. Since now we're in the first query here, the first part of the union statement, we are selecting the ID and username. Although here we specified username and password, it will still take the name of the column from the first statement. So that is why here we have ID and username instead of username and password. But of course the data is just username and password, so we got what we wanted. Okay, so let's just get back to our slideshow here. Next up is the error-based SQL injection. still, of course, in the same category of in-band SQL injection. So this technique consists in forcing the database to return an error, which is in turn shown in the application's response, usually a web application. And from the error message that's displayed, attackers can not only determine the point of the injection, so they can get more information about the SQL query used, because of course you never want to leak the query that you are using to perform any kind of tasks in your application, as that would make it easier for attackers to find the injection points. But other than that, the error-based SQL injections can also result in data extraction based on whether a query returns an error or not. So in this example here, we suppose there is a login function on this website, target.com, and we pass user quote, mind the quote here that's highlighted in red if that's apparent enough, and password, just specify any kind of password pass. So because we're adding that single quote here, and note that the query it looks just like this. We select everything from, oops, let me just get back. Yeah, so select everything from users where username is equal to quote user quote quote. So because we injected user quote, so it seems like we have two quotes here, which makes it error out, because it will find like a quote that's not matched with any other quote. So if we do the counting here, we have the first quote here, and then the second one here, third one here, and then we have and password equals quote. So SQL will see it like this. We have the first string here, user, and then we have the second string here, space, and password equals, and then finally it will find this, basically it will try to interpret pass here, not as a string, but as a SQL statement or something like this. And then it will find like the fifth quote, which doesn't match with any other quote, and it will find the semicolon in the end. So that's what the problem here is. We can see this practically on the terminal here. Let's just see the script of the SQL error-based SQL injection. So we have the database as always test, username user quote, password pass, and then the query, select everything from users where username is equal to quote the actual username input here, and then quote space and space password equal to quote the password input here, quote, and then semicolon. So if we just execute this, it should result in an error. Exactly. So it shows us that our query is just like this, just like it was indicated here. And then it says we have an error in your SQL syntax. Check the manual that corresponds to your MariaDB server, which is basically a kind of implementation of MySQL version for the right syntax to use near pass. So yeah, it basically finds that there is a missing closed quote. So that's what the problem is. So let's just continue here. Now we move on to a slightly more advanced type of SQL injection called inferential or blind. As opposed to in-band SQL injection, there is no actual error or data that's returned, or at least directly returned by the web applications. So attackers can extract that data by sending a lot of requests while observing the resulting behavior from the response. And this will be more clear when we get to know the two types of blind SQL injection, which are Boolean-based and time-based. So let's start off with the easier of the two, Boolean-based SQL injection. So it is a technique that ultimately consists in sending a lot of SQL injection payloads that force an application to return a different response based on whether the query returns a result or not. So in short, we're basically asking the database yes or no questions, which it would reply to, of course. Now in the illustrated example here, let's say we're selecting everything from the table, just like this in the query, select everything from the table where ID is equal to 1337. and 1 is equal to 0. Obviously, 1 is always not equal to 0, so the where clause is always false. That makes sense because here we are using and instead of or before. So because of this wrong condition here, it should always return false. And effectively, the application returns that the user doesn't exist, which should make sense. And this in the second query here, we're adding and 1 equals to 1 instead of 1 equals to 0. And we know that this query here is always true. So the truthness of this whole condition here should only rely on ID is equal to 1337. And this indeed returns user exists because we assume that we have a user with ID 1337 in the database. So now it's obvious that this example is a bit pointless, as we could have just sent ID equal to 1337 without the ands in the end, and we would get the response that the user exists. But another example that proves to be actually dangerous is that we can ask the database if the first character of a user's password is A, then B, etc., until we get a positive response, and we can do the same thing with the next character and so on. Now we move on to the time-based SQL injection attack, which is actually the one that really deserves to be named blind, because in this case no actual response is returned by the server. It's not like the Boolean-based SQL injection, where we at least get like the response of the Boolean question. For example, just like before, we can get the response in the same sense of user exists, user doesn't exist. But in this case here, we get no response. But the way to determine whether a query returns a result or not is by telling the database to sleep for a specified amount of time. What we mean by sleep is basically just delaying the response time of the query. So what we can do here is by telling the database to sleep for a specified amount of time. That way, if the result is true, the database will sleep for a number of seconds, and else it will be false. If it's false, it won't sleep. Now, how can we determine if the database returned true or false? We can just measure the time taken by the app to respond. So with that, we can determine whether the query returned a result or not. So let's see that with a more concrete example. We have here a vulnerable web application that's written in PHP, but we don't have to know about PHP. We can just look at the SQL code here. Anyway, the application forwards the user input into where clause. So we have here select everything from users where the ID is equal to. And then here we basically just get in the ID parameter. That's basically the user input. And then we close it off with a semicolon. Now, in order to determine whether the targeted user's password starts with a specified character, in this case A, because we want to start with A, we can use a payload similar to this one. So in the ID parameter here, we put this. Where ID equal to 1, we basically want to close the one here, and if left password 1, so basically this left function basically takes one character from this column here, password, and takes it from the left. So basically the first character of password, it compares it to the letter A here. And then with this if function, what we're doing here, we're telling it that if this condition here is true, sleep for 15 seconds, else just return nothing, return like 0. So in the end, it's processed like this. With the syntax highlighting, it might be more clear. So basically, just like as I was saying right now, if the targeted user's password starts with A, it will send the response after 15 seconds, which we can measure. Else, the server will respond immediately once the request is processed. And we can repeat this process for every, of course, letter for each character, of course. And with that, we can determine the password of a specified user, and then we can move on to the next user and so on. It of course takes some time, but it actually is effective. Now we'll go on to the last type of SQL injection, which is called out of band. It consists in extracting data using network connections, whether that would be using HTTP or DNS requests. It should be noted that out-of-band SQL injections aren't very common because they depend on some features being enabled on the specified on the DBMS used by the web application. And this following example might be a little complicated to understand, but let's just go through it step by step. So we suppose we have a web application at example.com that has a parameter ID that's vulnerable to SQL injection, and of course we control that parameter here. So just like it is indicated here, ID here is the parameter. We start with 1 and then quote, union, select, etc., etc. Let's actually now go into what this query is doing here. So just like we saw before, we were using like a union query here. So basically taking parts from the other type of attack. Union select and then 1, comma, load file, all of this, and then comma 3. I just want, before going into this important bit here in the middle, I just want to highlight that the actual application uses 3 columns to fetch from in the first part of the union query. So that's why here we want to specify 3 columns, and we can just put placeholders here, not really placeholders, but basically the dummy immediate values, so 1 and 3 here. Now in the middle, what we're doing here, so let's just go into it in the inside and go back to the outside first. So what we're doing here is using the concat function. It's basically just concatenates two strings. We have here HTTP, then basically we have a website here, HTTP column /attacker.com/. So it's basically the website that's controlled by the attacker, and then we're appending to it the version returned by the version function. This version function just returns the version of the DBMS that's running on the server. So basically we're just concatenating that with that. So we can basically have, if the version is, let's say 1.1, it basically returns HTTP column / attacker.com/1.1. So that's it. And then what we're doing now, load file, what the result of this concatenation here. So load file is generally used to load files from the file system, but in most DBMSs, this it should be like explicitly enabled, this feature of loading files. And what's interesting about this function is that if you provide it an HTTP URL, it will try to make that a HTTP request. So the attacker here, what they should be doing is running a netcat TCP listener. So basically, it's just gonna play the role of the attacker.com web server, and then it will just wait for any kind of connection. And as soon as we execute the query that's in here, it will show up in the logs of this command here, the netcat listener. And as we can see here, it tried to get /5.6.4, which is the version of the used database management system. So this was the out-of-band SQL injection, the final type of SQL injection. Now let's move on to automation and tooling. So as far as it was interesting to cover all the types of SQL injection, but we still saw that some types, like certainly the blind ones, take a lot of time and effort to basically reach our goals with it, whether that would be leaking data or inserting data, etc. So in this section here, we cover some tools that are used to automate SQL injections, whether that would be automating detection or automating exploitation. So some tools we can cite here. We have first the most important one, and I think the most used one, which is called SQLMAP. Then we have a slightly outdated tool called Advanced SQL Injection Tool. And we also have the White Widow tools. You can just search for them and you'll find them. Now we'll talk more about SQLMAP because it is the most known one or most important one. It's basically a Python-based open source penetration testing tool for detecting and exploiting SQL injection vulnerabilities, and it supports nearly all types of database management systems. Here we have an example usage of SQLMAP. We use the command SQLMAP, of course, after installing it. -u to specify the target URL, and now here it is, target.com, and then ID equals 1. We need to start hinting at it, at how the ID is used, or the parameter is used, and then with the -p option we can specify what are the parameters in our URL. So in this case it's ID, and then it will do all kinds of automated tests to determine first if it's actually vulnerable to SQL injection, and if it finds that it is, it will try to exploit it to extract data from the database and so on. We have here some recommended flags that I will try to go through some of them. We can specify a text file that contains raw HTTP requests to test from. We can also specify the level of test to perform. For example, if you want to do a very thorough test, like we're actually convinced that there is an SQL injection, we can make the level go up, for example, up it to 5 or more. And with that, we can just hint to SQLMAP to do more tests, to find more vulnerabilities, maybe trying to bypass some filters and so on. Also, we can specify the database to enumerate, the table to enumerate, the column to enumerate, and so on. We also have some cool options here. We also have other ones here, so we can specify, make it dump all databases, all tables, and all columns. We can also skip detecting whether the target has a web application firewall or not. So I'll talk about web app firewalls next, little later, but basically just wanted to skip that phase because it takes some time. Now we talk about defense mechanisms, because as a cybersecurity person, you don't want to focus solely on the offense part. You also want to get on the defensive side, and so that's why we want to talk about how to defend our web applications from SQL injection attacks. So the first point we can talk about, our first defense mechanism, which is the most common and important one, is using prepared statements with parameterized queries. So what are actually prepared statements? They're basically just a technique to kind of pre-compile the SQL query, in the sense that even if our input has some data that's kind of suspicious, like we have some quotes in our usernames and passwords, or some things that make the SQL query fail, it will basically just try to interpret it, to pre-compile it, so it escapes all kinds of characters that are built-in characters for SQL and so on. And by doing that, it basically eliminates all kinds of problems with the SQL injection. So that's why it's a pretty effective technique to use. Next up, we have the usage of stored procedures. Basically, stored procedures are like a feature in SQL. In SQL, basically, it can be compared to creating functions in programming languages or procedures. And so by doing that, by creating like procedures of, for example, let's say we're creating a procedure that's called retrieve users, and when we pass it the actual users parameter in the procedure, of course, not the actual statement that's inside, it will interpret it as like the real value, not like the whole query. So in that sense, we are basically creating a security layer between the accessible functions by users and the actual database. Next up, we also have user input whitelisting or blacklisting as a defense mechanism. So input whitelisting consists in defining that only specific inputs are accepted in the inputs, of course, of the web application. So let's say we have the username field that only uses alphabetical characters from A to Z. And if in the input, in the codes, in the web application's code, if we find that the username input has something else, like a quote, special character, or numbers, it will basically just refuse taking that input. So in that sense, we're basically protecting our inputs by specifying exactly what characters are allowed. There's also the counterpart, which is blacklisting. So instead of defining the characters that are accepted, we define the characters that are rejected or prohibited. For example, we can prevent from passing characters like quote, single quote, double quote, star, etc. So yeah, that's what input blacklisting is for. We also have like additional defenses that are quite important. So first, the application should use the lowest level of privileges when sending queries to the database management system. We can illustrate that with an example. So let's say a university has a website that returns to each user their own information, or each student, and of course it doesn't allow displaying information from for all students. So as that would be personal information being leaked by malicious people. But let's say there is a malicious attacker who finds an SQL injection in that website. So, and let's say they can retrieve all data. So that's actually first that's bad, because we're basically retrieving all data from all for basically retrieving personal data from users. But let's say they want to like change the grade for some kind of course that they've taken and so on. So just imagine how devastating that would be. But let's say the application, the database server is running as a low privileged user that only has access to select data from the students table. So in that sense, it won't allow inserting new data or updating data or even deleting data. So that's what we mean by using the lowest privileges, how that can be useful. Also, one more thing, using web application firewalls. So this basically just web application firewalls are basically like a security layer for web applications. So what WAFs can do, they're called like that. If they see the request, the HTTP request has some kind of suspicious characters that are of course configurable, it will basically just reject that request. So it basically just acts as a more advanced input whitelist or blacklist. So that's it for defense mechanisms. We have a few resources for SQL injection. We have, of course, I think the most important one, the OWASP cheat sheet series on SQL injection. Whether that would be prevention or also attacks. You can find that on the OWASP cheat sheet series website. Also have some interesting books, the Web Application Hacker's Handbook, and also a field guide to web hacking, real-world bug hunting. For the tools, you can find the links here. The tools that we cited before, SQLMAP, White Widow Scanner, and the Havij SQL Scanner, Advanced SQL Injection Scanner. Thank you for attending this workshop, and see you in the next one. Thanks.